with some basic kind of just algebra concepts. Writing the equation out of the line, and this is just in y equals mx plus b form. So we're given a slope here, that's our m. We're given x and we're given a y. So we're just going to plug this into y equals mx plus b. And just replace everything that we're given. So we're given an m, an x, and a y. I'm just going to plug them here. We get negative 4 equals negative 2 times negative 5 plus b. And then we just solve for b. We get negative 4 equals 10 plus b. We'll just go ahead and subtract our 10. We get b is negative 14. So we take our b that we got, we take our m that it gave us, and we write an equation y equals negative 2 x minus 14. Okay. So that's like basically an algebra 1 problem. Stop me if you have more questions over the And number 2, this is just a subtraction problem and function notation. It just means the f function minus the g function. The only thing you have to really be careful of is make sure you use parentheses on especially the second function. So we have 9 minus x squared minus our g, which is 3 minus x. The parentheses aren't really so much important on the first one, but they are on the second one, because this negative has to get distributed into both of those terms. So it becomes 9 minus x squared minus 3 plus x. And then we're just going to rearrange it by like terms. Negative x squared plus x plus 6. And a. On number 3, this one, we're given an f and g again, is gf of 1. So there's no sign there, which means it's going to be multiplication. Now, what we might think is, so we need to multiply these, write them out like this. Okay. That's going to be a little bit challenging, kind of messy, right? The thing is, we're just going to be plugging in 1 anyhow. So what you can actually do is just go ahead and plug in 1 at this point. So we then just do 1 squared minus 8 times 1 plus 1 over 1. It wouldn't hurt if you multiplied it, but really there's no reason to in this problem because we're just going to plug in 1 anyhow. So 1 squared minus 8 is going to be negative 7. And 1 plus 1 is 2 over 1 is 2. And negative 7 times 2 negative 4. Number 4, we're asked to find f of 2a, so another pretty easy one. We're just going to take this 2a and we plug it in for any x's, any and all of them. So both of these x's get replaced with 2a. So that f of 2a is 2a quantity squared minus 4 times 2a plus 1. When you square 2a, just make sure you square the 2 and the a. And it's 4a squared minus 8a plus 1. And that's it. So that's B. All right, page 1 down. We're going to skip number 5 for right now. It's pretty much the same thing as we've already done. So you can do that on your under practice. There's a few too many of those. We'll just skip that. All right, next one. Anybody remember what type of function is this called? Multiple. Anybody knows? Huh? Yeah, it's a piecewise function. Yeah. So it's got different pieces for different parts of the domain. So we use this function if we're less than 5 for the x. We use this one if we're more than 5 or equal to. So where do we plug it in? Top to bottom? Top, right? 2 is less than 5, so we're going to plug it in the top function. So we just do 3 times 2 plus 2. Which of course is 8. So those are easy as long as you know what you're doing. All right, this one might take you back a little ways here. What kind of symmetry does a function have? Anybody know what we do to find this out? Uh-huh. Yeah, you're right, yeah. So for x-axis symmetry, you do it to the opposite variable. So when we're looking for x-axis, we replace the y with negative y. So we go 5, and then negative y plus 3x squared equals 0. So we replace the y's with negative y's when we're checking for the x-axis. And then we just simplify it. This is just negative 5y plus 3x squared equals 0. And we just compare it to the original problem. If it looks exactly the same, we say yes, it does. If it looks different, we say no. This one does have one different sign, so it's going to be a no. For the y, we'll do a similar thing, except now we replace the x's. It's 5y plus 3 times negative x squared. Now notice this one is squared. When you square a negative, it does become positive. So 5y plus 3x squared equals 0. And that does look exactly the same as the original, so that's going to be a yes. And then we also have to test the origin symmetry. And so for that, we do both. You can probably figure that out without actually doing the work on this one. But let's figure it right out. So we replace both x and y, and then we can just put the results together. Negative 5y positive 3x squared equals 0. It's not exactly the same, so we'd say no. The only time it would be yes if it's not exactly the same is if everything's opposite. Remember, I did like dividing negative 1. So this one only has x-axis symmetry. Number 8, we think of those parallel, perpendicular, or neither, or coinciding. Whatever that means. What do you think? We'll look at the slopes, right? They're definitely not parallel, right? Because they're not the same. Parallel is the same slope. Are they perpendicular? They are, yeah. So perpendicular, this is they're negative reciprocals. Meaning if you were to flip it and change the sign, they're the same. This one, if you flipped it, it would become 1/3 and then change the sign to positive 1/3. So they are perpendicular. Let's go to the next page. Which line is perpendicular to y equals 2? Generally what I say when you have like a one variable equation is to just draw it You could probably guess and figure out this one, but I'll go ahead and draw it. It's just a good refresher to use one variable equations drawn. For y equals 2, what you do is you just go to 2 on the y-axis, and you just draw a straight line. Go up to 2 on the y-axis, and then just draw a straight line. Just think about any of these. If we're going to be perpendicular on a straight up and down line, that's going to be an x equals equation, right? X equals 2 here. You just go to 2 on the x-axis, and just go up and down line. So that's the only one that's going to work. That would be perpendicular. So 10 is another multiplication, but we actually are going to multiply it on this one because we have an x here. We don't have a number to plug in. So we want to write this as 4 minus x times x squared plus 3. And when we have multiplied two binomials, we have to remember to FOIL this one. FOIL. So you do 4 times x squared is 4x squared. 4 times 3 is 12. Negative x and x squared is negative x cubed. Negative x and 3 is minus 3x. And then we obviously just going to put it in the right order. Negative x cubed plus 4x squared minus 3x plus 1. And that matches B. Number 11 is a slope formula. This one is actually on your reference sheet, but everyone hopefully will know what the slope formula is. It's that y2 minus y1 over x2 minus x1. So pretty easy points there. x1, y1, x2, y2. Then our m, y2, which is 3, minus y1 of 7, over 2 minus negative 3. 3 minus 7 is negative 4. And then 2 plus 3, which is 5. Negative 4/5. Number 12 we'll do just because it has a fraction. Sometimes you guys struggle with fraction operations. So let's try that one. The setup's just going to be the same. Slope is our m, our x and our y. It's a good idea to always just write out y equals x equals b. And then just plug in directly where they go. Y is 6. M is negative 1/3. X is 8 plus b. So when you multiply negative 1/3 and negative 8, you get positive 8/3. Negative times negative is positive. And plus b. So then we need to subtract 8/3 over. You need to be able to do this as a fraction, not a decimal. So we got 6 minus 8/3. What do we have to do to that 6? How do we make it so we can combine those? Huh? What is 6 minus 8/3? Yes, man, is that multiply by what? 3 over 3. So it becomes 18/3. 18/3 minus 8/3. So 18 minus 8. 18 minus 8 is 10. 10/3. So then our equation is, we got our m. Y equals negative 1/3 x. plus n third. So number 13, we're just going to plug in 4 for the x's. So pretty straightforward, easy one here. 8 times 4 squared plus 7 times 4. 7. So 8 times 4 squared is 16. 8 times 16 plus 28 minus 7. 8 times 16 is 128 plus 21. And that gives us 149. All right, next page. Okay, how do we find the intercepts? Can you not do that? Yeah. Okay, go.
So use the y to 0 and x to 0.
You got it, yep. X intercept, you change the y to 0, put in 0 for y. But if we write it 0 for y, for x intercept. So this becomes 0 equals 3x minus 6. And then we're just solving for the other variable. So we just get 6 is 3x, and then x is 3. Plug in 0 for the opposite variable. So then y-intercept is just the opposite. Plug in 0 for x. Y is 3 times 0 and 6. Or obviously you should just know that y-intercept is then rounded by itself. That's the reason why. Y is negative 6. Right now, we'll just skip number 15. You can do that on your own, but it's going to be another equation there. If it's parallel, that just means it's the same slope. So we're just going to use negative 3 as slope. So now we get to do a little piecewise graphing here. We had a packet on this back in the day. I think I was absent one of the days. I had to do some of these piecewise functions. But basically what we did is we make a little XY chart for each of these functions. So if we were to start with the top one, make a little XY. You would always make sure that you plug in whatever these endpoints happen to be. Definitely plug those in, and then plug in at least one other point. So I'm going to put negative 3 because that's an endpoint, and 5. Leave a little space there. And then a number in between there, so like 0 would work. And then we just plug those into the function and evaluate it. So this will become negative 3, which will be positive 3 plus 4. Y is 7. I have to plug in 0, being negative 0 plus 4. Plug in 5, negative 5 plus 4, negative 1. So let's go ahead and graph this. Now pay attention to these signs here, because if it has a line under it, that means it's going to be a solid dot. If it doesn't, that means it's going to be an open dot. So be careful when you put these on. So negative 3, 7. 0, 4. When we do 5, -1, we want to put an open dot there. So we line like this, put it in the open dot. This doesn't include that point up infinitely close to it, doesn't include it. And then we do a similar process for the other one. The little XY chart. And this one only is starting at 6. So really let's do like 6 and 7. Get enough to get it close. 3 times 6 is 18, minus 5 is 13. 7 is 21, minus 5 is 16. And you do run out a little bit of space here, so let's move this a bit. And 6, 13 is up here somewhere. 7. This is a linear equation that goes. It is solid though because it's got that line underneath. Solid. We got 2 pieces to graph. I've got another one of these to practice here. Mostly on this for the exam, if you're given a multiple choice one, pick out which one would be the correct graph. So definitely pay attention to whether they open or close dots. That will be a big difference. So number 17. Yeah. We definitely want to include the 2 endpoints, so we want to include -5 and -1. Number in between for like -3 and 5. But with this, the function is just -2. So no matter what you try to plug into it, nothing will actually work. You just get out -2 every time. Take all of them. And then, so in graphing that, just pay attention. This is an open dot here because it did not have a line. So the -5, -2, we're going to start with an open dot. -3, -2, -2. That one is a solid, so just go straight there. And then our other one, we're going to want to include 0 and 4. And 2 is in the middle, so we'll put 2 there. Zero plus 1 is 1. 2 plus 1 is 3. 4 plus 1 is 5. So we've got 0, 1, 2, 3, and 4, 5. All solids, and then it ends. And we'll skip number 18 again for now. Take a look at 19. See which function you should plug it in there on number 19. You plug it in the top and the bottom. Yeah. Right, you can't actually do either. 4 is not between -3 and 3. It's also not more than 6. So this is actually undefined. 4 doesn't have that. Undefined. Now on number 20, we're asked if it's parallel, perpendicular, or neither. We're going to be looking at the slopes. Can we just look at what's attached to the x here and just look at the slope there? Yeah, it doesn't work because we have to rewrite it into slope-intercept form first. The slope of this one is not 4 and that one is not 3. So you can't just assume that. So what we do want to do is write out the equation and solve for y in both of these, and then look at the slopes. So we'll subtract that 4x over. And then divide by -6. Each term is divided by -6. And so we get y was -11/6 plus, and then we want to go ahead and reduce 4/6. That reduces to 2/3. 2/3 x. Now we'll do the same with the other function. Huh? 3x plus 2y is 9. So the same steps, subtract the 3x, divide by 2. You get 9/2 minus 3/2 x. Simplify that one. So now we want to compare the slopes, determine if they're parallel, perpendicular, or neither. You could exchange the places if you want to, but you don't have to. That one's plus 2/3 and minus 3/2. So parallel, perpendicular, neither. Yep, perpendicular. There's slopes and change. Formatting didn't really turn out that great, but it should be a +2 here. Down next line. So see if you know all these transformations. So what does that +2 do there? Up, down, left, right. It's going to go up, right. It's on the outside, so outside goes up and down, inside moves left and right. So it's going to be C up 2 units. Take the absolute valuations up to 22. You got to think a little bit more in depth in that one. We're given one function, x plus 3 squared minus 4, another function, x minus 4 squared minus 4. And you have to think about what's happening from this first function to the second function. So how much and which way is the function shifting? So from this one to that one. And also just remember, so the 4s are the same, not going to do anything. The inside is left and right, but it's also the opposite. So that +3 actually means left 3. We're going to be 3 to the left of the x-axis. And this one is going to be a right 4. So we go from a -3 left 3 to a +4, change of 7, right? So we're going to move it to the right side. Next up, we got vertical reflection and a horizontal shift. Vertical, we could also say, and I might even say this on the exam, is this a reflection over the x-axis. So reflection over the x-axis, and then a horizontal shift. Because vertical would be over the x. So let's see if we can eliminate some. You could, with a horizontal shift, that means left to right. You could eliminate this one, definitely right, because that's up and down. This one as well, because it's not inside the function. So between these two, really we just need to figure out where the negative sign goes. So with a vertical or an x-axis reflection, does the negative go inside or outside the function? Yeah, it's going to be outside. It's going to be C. Outside. Anything outside changes the y's. When you do a vertical reflection, when you reflect it down and up, it changes the y's. So outside changes y's, and inside will always change the x's. Outside is the y's, inside is the x's. Let's take a look at 24. 25 is really similar, so let's do 24. We got the absolute value function. Kind of look at this part by part. What is that 2 doing to it? What do we call that? Outside, so it's a vertical stretch. Right, vertical stretch. So vertical stretch. And you could even say like, we'll say by a factor 2. Means it's gonna like get 2 times as tall. Okay. And then we've got that -3. That's inside, so it moves it left and right. The opposite though, so it's gonna be right 3. And then the plus 2 on the outside is gonna be up 2. And 25 you can do on your own. It's pretty much the same thing. Let's get 25 now. Alright, I'm going to probably do this last page today. Alright, let's see if we can do a couple transformation graphs here. So we're supposed to use the parent functions and transformations to change that. First thing you need to know is, well, what is the parent function? Parent function is x squared, right? So think about what x squared looks like. It starts at 0, 0, and goes through 1, 1, -1, -1. Also 2, 4, -2, 4. Get that U shape. So I'm going to go to graph that. And then we have 2 things we're going to do. This -3 goes to go right 3. And that +1 goes to go up 1. So we'll just take all the points right 3 and up 1. 1, 2, 3, 4. Everything shifts right 3 up. This one's going to be a little bit more challenging. Huh? What's that? Yes, a little bit. Do we know what the cube root function looks like? Do we know? Kind of like the square root, except it has another part to it as well. So if you don't know what it looks like, it's okay. You could still figure it out. We could even make a little chart. Okay. Cube root of x. Little xy chart. So this is just the parent function. So if you plug in 0, you get out 0, obviously, right? So it's the origin. You plug in 1, cube root of 1 is 1. Plug in -1, you get out -1 as well. That's probably not enough for you to know what the graph looks like, though, because it's not just a straight diagonal line there. Right? It's not what it looks like. So let's plug in just one more, just so you get the idea. Plug in 2. Cube root of 2. Do you know what that is? Probably don't know what it is. What's actually the best number to plug in? Do you remember? What number do you know the cube root of? 8, yeah. 8. The reason why we choose 8 is because the cube root of 8 is 2. So we actually have to go out 8 to get 2. Somewhere out there. Right. So this graph, and then if you plug in -8, you would get -2. So somewhere out here. Right. Doesn't have to be exact. It's a sketch, but this graph looks like this. The square root just is this part, much more shallow. The cube root is both sides. All right, now we have to transform this a little bit. Let's think about everything it's going to do. It's going to stretch here, right? It's going to go to the left 2, and it's going to go down 1. And we're going to kind of work from the inside out, if you will. So let's take each one of these and apply this here. So we're going to move it to the left 2. Let's just start with this middle one, left 2. For the 2 on the outside, we would stretch it so it's essentially just going to multiply the y coordinate by 2. Well, it's already 0 though, so that's not going to move. And then we go down 1. So right here. And we'll really just go left and down 1. For this one, left 2. But if we're multiplying it by a factor of 2, then we go from a height of 1 up to 2, right? So left 2, go up to 2. And then we're going to go down 1, so it's actually going to end up practically the same spot. And then this one, left 2, 1, 2. Stretch it by a factor of 2, so then it's going to be stretched down -2. But then we also got to go down additional 1, so down here as well. And then just kind of sketch in the same shape. But it's going to be stretched out. And if that's a little too hard, you can always just make like another XY chart too. But again, on the actual exam, you won't have to graph this by hand. It'll be choosing the correct graph. So if you struggle a little bit with the graphing by hand,